Hi, Jianwei. Can you help to share the screen?
Yeah, of course. Okay, let me share. Okay, so can you see the screen now?
Yeah. Okay, thanks. Today the May 30th, 2023, Tuesday. And today I'm gonna to share the features in the coming release. And okay, let's next page. Hi, hello, Jianwei. Next page.
Oh, okay.
Yeah. Before sharing the features, I'd like to talk about the Karmada releases. Karmada release follows the semantic versioning schema, and for the major release, usually contains large feature and architecture changes. Major release usually incompatible with previous release, and we are now in V1 and no plan to bump to V2. For the minor release, usually contains feature enhancements and bug fix that are introduced in the backward compatible manner. We usually cut the minor release in every 3 months. The next release is V1.6. For the patch release, for the patch release usually contains backward compatible bug fix and minor enhancements. And patch release is cut when critical fixes are required, or roughly each month. Okay, next page. Here is the highlight features in the next release, and we have several features in the release, and I like to invite feature owners to share the feature details. Okay, next one.
Okay, so it's my turn to introduce you about Federated HP. So the motivation is quite simple. We need to scaling workloads across multiple clusters. Like there is more resource in one cluster, we need to scale there more workloads there. So also we need to, before many clusters, we need to manage them separately, one by one, the HP resource. So now we just need a unified many-phase YAML to manage them. So here is a picture about the steps 1, 2, 3, 4, and the step is quite simple. It's almost same with the logic of the original HP controller in Kubernetes. So the first step is there is one HP controller in Karmada Control Manager. It will quarrel matrix through matrix API, like matrix .kbytes.io with label selector predictly, maybe 10 seconds. Then Karmada API server will get the matrix API quarrel, and it will route to Karmada matrix adapter. So here is a new, there is a new component called Karmada matrix adapter. They will registration the API service. Then the API server can route the request to Karmada matrix adapter. Then the third step, Karmada matrix adapter will always list and watch the member cluster pods. So when the request comes, it will query matrix from the target cluster where the pod exactly exists. So after matrix are connected, it will grade them and return to the API server. So then HP controller will collect the desired replicas based on the matrix and scale the workload directly, like scale up or scale down. So then After the workload is scaled up or down, then Karmada scheduler will schedule the workload based on the real-time overall status of all the master clusters. Like if you use divided, or then if there one cluster with more resource, then the scaled up workloads will be scaled more to there. So from the overall of the steps, so you can see there's some limitations like large workloads, there is many workloads require significant byte widths. And then also, it will, in the control plan, it will cache the pod status and matrix in the memory. So the control plan requires high CPU and memory cost. So here is a limitation. So in the future, we expected to introduce a distributed multi-cluster HBA to overcome these limitations. Thus, the calculation and matrix collection will be executed in member cluster. So the byte widths and the memory and CPU cost will be low. So here is the overall about this new feature in this release.
Okay.
So that's all. Thanks. Okay, next page.
Hello,
can you hear me? Can you hear me?
Yes, we can hear you.
Okay. Okay. Hello, everyone. I'm James from the Karmada community. Today, I will introduce a new feature that is application failover. In fact, that in the past release, Karmada has supported a cluster failover. That is, when a cluster is not ready for a 12 period, Karmada will automatically migrate it from the failed cluster to a new cluster. However, it will not cover some use case. Let's look at the left picture. Assume there are 3 member clusters and each of them has online and offline services in clusters such as jobs and deployment, and they do not have direct relations. So when one of the job failed because of multiple reasons, such as this is preempted by an application of high priority or lack of resource and other reasons, we want to migrate the job to other clusters, but we do not want to affect the running deployment. So in this case, we need a new failover from the perspective of application. That is application failover. There are 2 key steps in application failover. One of this is detecting failover. It is based on application health state, which can be customized by users in the interpret health operation of the Karmada's resource interpreter framework. The second is migration. Now we have 3 migration ways to migrate these replicas to other clusters. The first is immediately we will immediately delete the old replicas in the failed clusters. And the second is graciously we will wait the application is healthy in the new cluster, and then we delete the old replicas in the failed cluster. The second is never. That is, we will never delete the replicas in the failed clusters, and let users decide whether to clean up the redundant replicas. This is the overview of application failover.
Okay, thanks. We're gonna have the Q&A after the presentation. Okay, next one.
Hello, can you hear me?
Yes.
Hello everyone. In the new coming release version, we add a new repo, multi-class cloud provider. This repo defines the shared interfaces with Karmada cloud providers implement. Those interfaces allow various controllers to integrate with any cloud provider in a pluggable fashion. Let me let me describe the background. To enable Karmada to run the public cloud platform and flexibly use and manage other basic resources and services on the cloud. Cloud providers need to be implemented and their own adapters. However, in the implementation process, some works are the same for each cloud provider. Learn from the experience of the CCM. Karmada can also provide a public repo that provides the interfaces for using and managing basic resources and services on the public cloud. Cloud providers only need to implement those interfaces to provide users with their own adapters. Here is the repo address. Hi, Jeremy, can you show the next page?
Yeah, of course.
Thanks. Let me describe the process steps. First, ops version can deploy a set of applications on the Karmada control plane. It has two versions, V1 and V2, with corresponding to two services, V1 and V2. The resources are propagated to the member cluster, class A and class B through the propagation policy. Second, ops can create a multi-class ingress resource in the Karmada control plane and set the previous two version service as the backends. And the third, after multi-cloud provider can access, it means the cloud providers. This component will watch the creation of a multi-class ingress object. It will register the IP address of the service to the load balance instance, and then the multi-class cloud provider component will implement by a specific cloud provider. And first, user can access the different version of the service through layer 7 of OSI. 6 is all. Any question?
Okay. To be simple, the MCA cloud provider aims to manage the service across multi-cluster, and the implementation of a MCA cloud provider takes the responsibility to register the endpoint to their load balancer, and so after that, user can access the service in a way like ingress. Yes. Okay. Next page.
Okay, let me introduce the Karmada operator. Now we have several installation of Karmada, such as Helm chart, Karmada CTL, and local app Karmada, a script for testing environment. In the next release, we will introduce new method for installing, upgrading, and deleting Karmada instance. It will provide convenience to manage the entire lifestyle of Karmada. Besides above, it will also can customize Karmada instance such as set Karmada component replicas or custom labels and annotations of Karmada components and other Karmada API server SAMs or install Karmada add-ons like Karmada Descheduler and so on. So if you want to try Karmada operator, you can have a quick start at the following link. And welcome to contribute to Karmada operator. Thanks.
Okay, thanks. Next one.
Next one is the resource interpreter overview. First, let me briefly introduce the resource interpreter framework. It is mainly to parse the resource structure because Karmada do not know that the structure of users CRDs. So it will do several functions such as parse replicas when propagating deployment when users set the propaganda policy is divided and set several replicas in multiple clusters, and it can filter useless field in status, which Karmada control plane do not care about. And for resource interpreter framework, we have multiple interpreters. The one is built in for some Kubernetes native resources like deployment or state set and so on. The next is customized interpreters, which can let users to customize their own CRDs. There are two configurations for customized interpreter. One is the webhook, and the two is the other one is the declarative configuration, which allows users to use Lua scripts to define the interpreter options in the resource interpreter framework. Hi, Jianwei, can you next page?
Yeah.
And in the next release, we will add some well-known third-party CRDs into our built-in resource interpreter, and I believe it will help users to save efforts to customize third-party CRDs, and also it will help users help Karmada to integrate the Kubernetes ecosystem more smoothly. So now in Karmada 1.6, we will support the following CRDs, that is Argo Flow and OpenCluse and FluxCD and Kimono. This is verified by the Karmada communities and the third-party resource interpreter scripts are now hosted at the following link, and we really welcome the contributors to contribute more CRDs. One of them maybe like CNCF objects to the Karmada community. It will help more users to save efforts to integrate some well-known projects, and thank you. This is all my turn.
Okay, can I start?
Okay.
Yeah.
So okay. Here we use Killer Quota to use to build a playground for some new users. Like the motivation is simple. It helps them to get started with online environment. So the current playground link is here, Kilakota. We can see how it looks like. So you need to log in with your with my use GitHub. Sorry, Karmada. So here are 4 examples. The first one is propagate workload with duplicated model. Second is with divided model. And third is you need to install with Karmada-CTL. The fourth one is we simulate cluster furniture, and we then migrate the workloads from the furniture file cluster to the to another one. Guys, you can try after the meeting. It's quite simple. You just to click and everything go. So this examples is hosted in this repo, and if you if you have other great example or demo, you can add it to here.
Yes.
Okay.
Thank you. This is all about the features in the next release. And do you have any questions?
We have the intro slides from last time. I didn't find it on the agenda doc. Thanks.
Sorry, I can't hear you clearly. Jiangwei, I will mute you.
Okay. Sorry, can you hear me clearly now?
You can even choose.
I can hear some noises.
Okay.
Oh, your background noise is really bad. If you want to Slack me your question, I can repeat for you if mine's not as bad.
You can try now.
Hung Kai, Yao's question is, can we have the intro slides from last time? I don't believe the agenda has a link to the slides from the previous presentation.
Okay, sure. How about that? I put the slides to Google Doc and send the link to the Zoom channel. Is that okay for you?
I think for today's presentation, that's in the Google Doc, but I think, Yao, correct me if I'm wrong, but I think Yao was asking actually for the previous presentation.
Yes, yeah. For the previous meeting slides, I will put it to the Google Doc tomorrow.
Awesome. That works great. Thank you very much. And thank you for today's presentation as well. And we appreciate the slides today. We've been following along.
Okay, thanks. Okay, if I will send the release updates to the mail threads also. And okay, if no more questions, we are gonna to end the meeting. And note that. Okay, another question. another question. Any limitations in terms of number of resources can be managed by Karmada? Yeah, that's a good question. Many people ask the same question, and actually we have tested the performance last year, and the testing are running against the 100 clusters, and with I can send the testing report to the chat. Hi, Tiecheng, can you help to send the report link?
Of course. Let me wait for one. Yes.
Yeah. For now, we don't know. Karmada can support how many clusters, but from the test we can see Karmada can works well with 100 clusters. Yeah, because the test is limited for the resources we are testing. Yeah, Yaolin, I don't know if I answered your question.
Yeah, thanks. So from this report, it's like we tested like 20K pods can be managed by Karmada for all the clusters, right?
I'm sorry, you tested the 20 what? I'm sorry.
If just accounting the number of resources, say we have many small run to completion jobs. So is this 20K, I assume, is the upper limit?
And I could provide maybe some more clarity on that if I understand Yao's question right. So for example, with Karmada supporting Argo workflows, if we had a lot of individual Argo workflows, and so we're creating many resources with Karmada tracking those in etcd, what would that upper limit be? Would that be equivalent to maybe the number of pods? So we could assume that that might be around the range of 20,000 workflow jobs?
Yeah.
Or would that scale better or worse for those types of resources?
I don't test with the Argo workflow yet, but Karmada actually Karmada doesn't create pods directly. If you are propagating Argo workflow CRDs with Karmada, actually Karmada only focus on the Argo workflow CRD. Yes, after the CRD, maybe after the CRD is deployed in the memory cluster, the controller takes the responsibility to create the pods. So I can't see any problem here. But we are glad to he had the feedback about that. Have you tested? So we need to manage many small run to community jobs. Many small run to completion jobs. 20K. I guess Karmada can handle that 20K. I think so.
What I mean is that do we have a upper limit stats for Karmada's capacity in terms of number of jobs?
Have the capacity what? Capacity?
Like a exact or rough number of upper limit. Not so I assume the 20K is what you have.
Actually, Karmada don't have such limit.
I assume you have not done like a real scenario test to find the limits yet. So 20K is I assume here is definitely something you can handle, but it's not limited to 20K, right?
Yeah, exactly. Because the test environment is the resource is limited, like the CPU and memory is limited. We can't find like an infinite CPU and memory to test the sceneries.
Yeah, cool. But that I understand. So yeah, if there's any stats for that, any number can be published for that, we'll be happy to be notified. Thanks.
Sorry,
she just said that if there is other, like testing about the report, like new threshold, is happy to be notified.
Okay. Yeah.
Sorry.
We
just
are.
Yeah. So sorry. Maybe being notified is a strong term, but it's just something
Okay,
our team is focused on.
Yeah, we let me see. We might need to retest the performance this year, but I'm not so sure yet. But if we run the test again, I will send I will send the notifications to mail thread or Slack. Okay, fine, thanks. Now we don't have enough time yet. It's time to goodbye. Welcome to the meeting and thanks for the time. The video will be published to YouTube and I'll send the link to the Slack channel. Thank you. Bye, guys.
Thank you, Hongkai. Bye.
Bye. Bye, Mike.
Bye.
Thank you. Bye. Yeah. Bye.